Okay, apa tu? Kita ada dua yang apa Korean, ini pun ada cuma berapa? 2, 4, 6, 8, 9, 10, 11. Okay, we'll wait for your friends ya, lagi 5 minit. Sebab this is a very important apa tu introduction so that you will know what we are going to do in the class. Kita tunggu lagi 5 minit 12, 5 minit. Ramai lagi tak ada ni. Okey, kita boleh mulalah kot. Semua dah ada ke? Okay. This is KH483 wastewater treatment, right? Okay, since this is a small class and we have 2 international students, I'm not sure whether they are in or not. Okay, I think I would like to know everyone, please turn on your camera and tell me what's your name, boleh ya? Name, because I want to know everyone who is in this class, KH4483, Okay, can we start now? Okay, actually I have the list, but okay, let me take the list first. Okay, the first one, Muhammad Amirul Razali.
Saya Prof.
Can you please turn on your camera so that I know?
Saya pakai PC Prof, tak ada webcam.
Oh, tak ada webcam. Okay, it's okay. Muhammad Amirul ada. Muhammad Fakrullah. It's not in ya. Muhammad Fakrullah is not in. Maybe those who are not in, maybe they have changed class. I'm not sure. So please, can you tell your friends? Muhammad Fakrullah, Ahmad Yusof. Ahmad Yusof, are you in here? Ahmad Yusof. Ahmad Yusof. No, Ahmad Yusof. Because we'll do I'll divide you into groups, so I need to know whether you are still in the class or not. Ahmad Yusof is not in. Muhammad Amir Ashraf. Okay, can you turn on your camera?
Ada yang tak accept student.
Ada apa dia?
Prof, ada yang tak accept student masuk kelas.
Oh, ya ke? Sekejap. Kat mana saya tak accept? Kat mana saya tak accept? It's quite a long time that so where should I accept? Mana? So I should go to meeting option. Is it meeting options? Meeting option. Is it in meeting option? I forgot lah where to accept. Do you all know?
Dia kalau join pakai kod tu dia tak perlu nak accept, dia terus
masuk. Kat mana nak accept ni? Now we have already 19 students in the meeting. Actually we have 22. So kat mana nak accept? Kat mana nak accept? Can you all join using the code that I gave in the WhatsApp?
Can, Prof. Can.
Okay. Okay. So we continue. Right? Those who is not using the code, please use the code. Muhammad Amir Ashraf, are you in here?
Yeah, I did.
No. Muhammad Amir, no. Muhammad Hizami.
Doktor, ada doktor. Saya.
Okay. Semua tak on camera lah. Saya nak tengok lah muka yang handsome tu semua. Okay, Suhail Azmin. Ni Muhammad Amir Ashraf. So you are in. Muhammad Hizami. Muhammad Hizami. Okay, Muhammad Hizami. Suhail Azmin. Okay, Suhail Azmin. Where are you? At your home or at the campus?
Campus, Prof.
Oh, all of you are in campus, right? Okay. Muhammad Hafiz. Muhammad Hafiz bin Kamari. Mana? Oh, ni. Okay. Okay. Who else? Nur Fariza Hafiza. Nur Fariza Hafiza.
Ada doktor.
Okay. Can I on the camera?
Yeah.
Muhammad Abid. Are you in? Muhammad Abid. Farisa. Okay, now. Abid.
Ada.
Mana muka Abid ni?
Saya
Abid tak boleh on kamera.
saya pakai external webcam tapi saya tertinggal kat college, Prof.
Oh, so where are you now?
Saya kat rumah. Saya balik sekejap lah.
Oh, okay.
Okay.
Muhammad Abid. Aizat Abdul Rahim.
Saya doktor.
Itu.
Hai.
Okay. So you kat rumah
Saya
dekat kampus.
kat kampus tu.
Okay, Aizat. Nur Syahira Syamimi.
Saya Prof.
Okay. Nur Syahira. Muhammad Amirul. Muhammad Amirul. Tak ada Muhammad Amirul. Muhammad Amirul Hasnan.
Ada lupa buka mic.
Oh, okay. Muhammad Amirul. Muhammad Dirham.
Saya doktor.
Okay. Ada. Kat rumah Afrina Yusra. Okay. Tak ada Afrina Yusra tak ada Nur Syahimah. Oh, ada. Nur Syahimah.
Ada Prof.
Ada. Semua malu. Muhammad Syimir.
Yes, doktor.
Muhammad
Ada?
Mana dia?
Ada.
Tak kamera.
Tak ada kamera.
Oh, okay. Muhammad Syimir. Okay, Muhammad Ashraf bin Abdul Salim. Ada dua Ashraf bin Abdul Salim. You Muhammad Ashraf. Muhammad Amir Ashraf. Okay. Nur Fatih Naziha. Are you in here? Nur Fatin tak ada Nur Fatin tak ada. Zazmizul. Okay, and I think we have 2 Korean students. I'm not sure whether they are in this class yet or not. Okay, Korean. Actually, I clicked the link, but the pop-up said I need an authorization of access. Oh, so you need to use the code, Okay, we'll wait for her. Okay, so do you know any of your friends that dropped this class? We have 20 students actually now.
Don't know, Prof.
You don't know. Okay. This is the small class. I hope that all of you can get A, because if it is a small class and I can justify that that you are fit to get A for this class, I'll give all. Okay, because this is a small class, so I expect that everyone can easily ask question. And whatever that you need to do, you must do, and I can give more attention. So we have 2 Korean students, but so you need to use. I think they are in our group, right? Abid has already invited them. Okay, so for today, I'm going to give you an introduction, and also if I think we will have time to finish the first part of our lesson today, because actually last week we have already missed 1 week, but it's okay. I think we'll still have ample time to complete the syllabus. Okay, while waiting for your friends, I'll share the slide that I'm going to use for the introduction of the class. And because I'm going to also divide you into groups for the projects, okay, for the design project. Okay. 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 Still not able to. Okay. Can you see my slide? Can you all see my slides?
Yes.
Oh.
Yes, Prof.
Last time the team is not working well, so I used the link to enter the lecture, but today the link has, oh, okay, so where should I accept? I almost forgot because it's already a few months back. Manage permission kot ni. Manage permission. Yes, I said that I give permission to everyone to bypass the lobby. Let callers bypass the lobby. Yes. Announce when callers who can present everyone. So I think I don't have a problem with this. So what is the problem now? What is the problem now that these students cannot participants manage permission? I give permission. I give permission. You all tahu tak dekat mana nak accept yang permission tu for these two students? Semua ada, okey. Masalah dia. Okay, give me 3 minutes to solve this issue. Okay, manage permission. I've already. Okay, more rooms automatically. Okay, this is the breakout rooms. No. Participants, share invites, copy meeting link, I give to okay. I think they are in Korea. That's why it's very difficult. It's okay. I think I've already given the new link to her and him. We have 2 students, but it's okay. I think we should start now, and hopefully that finally she can join the class. Okay. Can somebody record? Start recording. Okay, start recording. Okay, then I share the slide. The slide with you. Can you all see my slide? Students, can you see my slide?
I cannot, Doctor.
Huh?
I cannot, Prof.
Sudah.
I cannot.
Cannot, Doctor.
Nampak tak?
Dah keluar. Dah.
Dah keluar. Okay. Okay. So the only lecturer for this course. So this is my phone number. And this is my email in case that you need anything. And I forgot to tell you, my office is at the new building. The administration building, level 3. And as you go to level 3, you need to go to your right. This is where my office is. Okay, and this is my email. Okay, so the synopsis, this is a requirement that we need to tell students what are the objective and outcomes for the course that we want students to achieve. How many of you have taken actually wastewater treatment? Any of you? Last semester?
Yes, Doctor.
How many of you? All of you,
Yes, Doctor.
Tak,
Oh,
Prof. Certain je.
Okay. Most of you have taken wastewater treatment. So this is, I think wastewater treatment is more difficult compared. It's not difficult, but it's more difficult than this water treatment. Because water treatment, usually the source of water to be treated is much easier. So I hope that everyone can get A for this class. So for the synopsis, I'll just read through and just make sure that you know. The course will begin by covering the fundamentals that are necessary to understand water qualities and criteria and what process units are required for water treatment. Quality criteria for different water users, potable water, irrigation water, water reuse, and more will be discussed, as well as the characteristic of the different water source. Surface water, groundwater, and lake water. Actually, lake water is also surface water. The chemical, physical, and biological processes involved in water treatment will be described. There will be a focus on the operational units and processes, sand filtration, disinfection, flocculation, coagulation, water softening, disinfection, and these are quite different from the wastewater treatment. Students will also be familiarized with new technologies like the membrane filtration. Okay. Course learning outcomes. So we have 4 CO or hasil penilaian kursus. So one of the first CO is ability to apply knowledge of physics, chemistry, microbiology, and fluid mechanics to perform engineering analysis and design calculation for water treatment systems. Ability to clarify the water quality criteria for different water sources and usage purposes. Ability to propose a water treatment process for various water sources and usage based on the fundamentals of the operational units. And ability to design basic treatment processes applying the concept of water treatment principles. Okay. So this is the teaching plan. I'll make a very detailed teaching plan so that you know what will be covered in the course. So the first week, actually water sources and water quality, regulations and standards. So I think I will manage to cover these 2 weeks during this week. So today, water sources and water quality, and then for the regulations. Okay, so this is actually just an introduction for your course. And on the third week, we will have topics on sand filtration. Fourth week, coagulation and flocculation process. So this is also one of the topics for wastewater treatment, but for water treatment, it is a very, very important process. Project presentation 1. So the project will be, I think it's not that difficult. So there will be only 2 presentation. Project presentation 1 and also project presentation 2. And then on the 6th week, we have this Idul Fitri holidays, the 2nd and 3rd May. And then we continue on the 7th week with water softening and adsorption process. So if you see that I make any mistake on the on the table here, please let me know, especially on the date. And then we have mid-sem break, and then on the 8th week we have water softening and adsorption process. 9th week water disinfection. So if possible, I want to cover actually as many topics as possible before the mid-sem break. But it's not enough because when you present your project presentation, I want you to have at least some knowledge so that you can, and don't worry, but this project presentation 1 is not detailed design. So on the 9th week, we have water disinfection. 10th week, membrane filtration. So this membrane filtration, if possible, I would like to invite somebody from industry that have this really real experience on using membrane for water treatment. And then on the 11th week, moving bed biological treatment for organic and nutrient polishing. As you can see, most of the topics are on the physical and chemical process, but also when you want to use small amounts of organic, you can also use biological treatment. So this one, I'll put this in on your 11th week. And on your 12th week, you will have final project presentation. And 11, 12, final project submission. Okay, I give you 1 week after your presentation. Maybe you need to make some correction. And then final project submission, and the 14th week is the revision. Okay, you can stop me anytime if you want to ask any questions. Okay, these are some of the references that you can use if you want to get more on the content of the course. Okay, modes of delivery lectures. AST1. Do you know what is AST1? Where is it? Any of you have gone to this room, AST1? Any of you? No.
I didn't.
Okay. I want to ask you, are you all comfortable with this online, or you want to have this physical meeting? Do you want to have physical meetings? Okay, actually the requirement is at least we need to have 4 physical meetings. So I will try to find what is this room, and then we'll try to arrange the physical class. Okay, on the assignments, contributes 5 to 10% towards the total marks. So I will also, if let's say for that week I finish that syllabus, I will give you quiz. If not, then I'll give you assignment. Water treatment design project 30 to 50%, and final exam 3 hours, which cover all parts 30 to 70%. Okay, so for your water project, water treatment plant project, I will show you. This is the water quality characteristic of River Ganga at different sampling sites during 2017. So this is the parameters of the River Ganga. Let's say if you want to use this river water and treat it using your treatment plant. So this is what the quality characteristic that you need to find from the literature. Okay, and these are some of the water quality. Water quality basically is based on physical, chemical, biological, and aesthetic characteristic of water. Because even though aesthetic is not harmful, but still if you want to use it for water supply, you need to make sure that it is aesthetically pleasant for you all to use. So you have these physical parameters, chemical parameters, and biological parameters that become the concern of water supply that you need to have. Okay, so for your water treatment plant design project, first you have to evaluate. First, I want you to each group. Each group, I want at least 3 of these. And from the parameters, you will find a reference or literatures of any wastewater characteristic that have that pollutants, contaminants in terms of that parameters. Let's say 3 parameters you choose. You tell me what will be the parameters of your concern, and you choose and you find any references that give you these contaminants in the water source. And I want you to then you have to identify the specific source for water supply, meaning that from your reference, from your literature, you tell me where is the location of this water source, and you have to give me the characteristic of that water source, and you compare with the standard water source for drinking water. So these 3 contaminants, you need to show that these 3 contaminants, you can have more. These 3 contaminants are higher than what you have in your standard. Then explain the quality of the source and compare it with that of the standards. So this is for your oral presentation number 1. So meaning that you have to tell me what are the characteristic of the water source that you want to treat, and then you also have to determine the location and also the water demand, meaning that how much water will be treated in your treatment plant. Because in any design, you not only the characteristics of the water source, but also the amount of water that you need to use. So this is oral presentation 1. And then with the obtained characteristic of water, design a drinking water treatment plant that will ensure safe water intake. Prepare the process flow diagram. So this is everything will be presented in your final oral presentation. As I mentioned, you will only have 2 presentations. Presentation 1 and final presentation. So perform the mass balance for the whole treatment plant and determine the characteristic of the treated effluent and compare with drinking water standard. Show the detailed calculation of each unit operation involved in the proposed treatment plant, and prepare a complete report starting with the background of the source water, the design, and the treated effluent. Oh, okay. So shouldn't be here. Okay, so the proposed contents for the report, should be chapter. You need to have an extract. Chapter 1, Introduction, Water Demand and Sources for a Community, Water Safety Issues, Comparison with Environmental Regulations. This is where you show the characteristic of the water source, and you have to make sure that there are 3 parameters that have concern with the standard regulations. So you need to make sure that your treatment plant will be able to treat these contaminants. Chapter 2, the proposed water treatment system, a description of unit process. And chapter 3, detailed design of each unit in your water treatment plant, the material balance to quantify process streams, meaning that whatever comes in from your unit operation must come out from your unit operation. Environmental and safety issues, this is where you compare your effluent, your treated effluent with the guidelines. Just you have to make sure that using your in your treatment plan, the contaminants that you have chosen, the 3 contaminants parameters, you'll be able to remove using the treatment plan. And then conclusion and also references. Okay, any question? Any question? Okay, no. Okay, actually, this is my proposed. Actually, randomly, I put you, every one of you, into 11 groups because there will be 2 people in the groups. So I'm not sure whether any of you have already, any of the students dropped this. So actually, this is the names that I got from the SMP web. So this is the first group, Muhammad Amirul with Nur Farisa, Muhammad Fakrullah with Nur Syahira, Ahmad Yusof with Afrina, Muhammad Amir with Nur Syahimah, Muhammad Hizami with Nur Fatin Naziha, Suhail with Muhammad Amirul, Muhammad Hafiz with Muhammad Dirham, Muhammad Abid with Muhammad Shimir, Aizad with Zasmizul, Muhammad Ashraf with Kim Iyuns, and Ahmad Luqmanul Hakim with Sio Min Siok. Okay, so up to date, this is my list, but maybe if any of you are not in this class, any of your friends are not in this class, then I will make some arrangement how to have how many groups we need to have. Okay. Okay. Do you have any problem with this? With the group that I've already decided for all of you? Okay. So diam semua. So I think you all agree. Okay. This is the introduction overview of the class. So do you have any question to ask me? Students, do you have any question to ask?
So far, okay, Prof. Ada soalan?
You are okay, good. Okay, so okay, we'll go into today's lesson. I will stop presenting this slide. Okay, I share with you, with all of you, another slide for today. Okay. Okay, can you all see the slide? My slide?
Yes, Prof.
Okay. Okay, okay, good. Okay, we'll start our lesson. You can stop me anytime if you want to ask anything. Okay, water sources and water quality. So actually this is the introduction for before you actually your main objective is to treat the water your water source. Okay, Okay, water sources and water quality. Okay, so this is all about water. So actually water is a common chemical substance. You know that it is essential for survival of all known forms of life. So actually water refers only to its liquid form. When you say water, it's liquid form. Okay, but actually the substances, the water, it is also, you'll be able also to find water in the solid, which is ice, and also gaseous state, water vapor or steam. Okay, so so the water resource, water resource, you know that all water on earth, actually about only 1% is used, is used by humans, only 1%, unusable 99%. So and also rivers water and lakes only 0.02 and 0.86%. So most of our water, our used water is, our available surface water is, our available water is groundwater. So surface water is 97% salt water, ocean and seas, 2.4% glaciers and polar ice caps, 0.6% other land surface water such as rivers, lakes and ponds. So the groundwater, all water, when we say groundwater, all water that saturates the tiny spaces between this deposited material or alluvial material, you can say sands, gravels, shale, clay, or fractures in rocks. So this includes the aeration zone, aquifers, saturation zones, capillary water, and water-bearing rocks. So our concern is to know about the water quantity. I think this one you have already covered in your subjects on water resource. The timing and total yield from a watershed and is measured by total yield and peak flow over a specified period of time. And the water quality is very important world economy because water plays a very important role in the world economy as it functions as a solvent for a wide variety of chemical substances and facilitates industrial cooling and transportation. So water is a solvent, important solvent, so it gives very important, it plays a very important function for the world economy. So approximately 70% of fresh water is also consumed by agriculture. And water also provide livelihood and economic security because different bodies of water provide in different countries. This maybe some countries need more surface water, some countries need more groundwater. So different bodies of water provide livelihood and economic security to different countries. Even in Malaysia, maybe some states we use surface water as our potable water, but in some other states like Kelantan, maybe they use lots of groundwater. So different bodies of water provide different livelihood to different countries or states. Okay. 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 So this is objectives or necessity of protected water supply, because you want to supply safe and wholesome water to consumers, and you want to supply water in sufficient quantities. You can have water, but if it is not sufficient, then it is also a big problem to you. to supply water at convenient points and timings, to supply water at reasonable cost to the users, and to encourage personal and household cleanliness of users. So components of a protected water supply scheme, you have source of water, intake, treatment, distribution. So for your other class, I think you have already covered source of water, intakes and distribution. So for those of you who take this elective course, you will explore more on the treatment of water supply scheme. Okay. Okay, so water demands or per capita demand. It is the amount of water required by one person per 1 day. It includes domestic use, industrial and commercial use, public use and waste. So per capita demand, because in your project you also need to tell me what is the per capita, the demand of the water the total quantity of water required by various purposes by a town. Usually, you can easily find what is the per capita demand for each country. Malaysia, how much per capita demand of your water? How much? What is the per capita demand for Malaysia? Any of you knows? You have taken many water classes, right? What is the per capita demand for Malaysia? Meaning that if you want to design something, you want to know what is the, when you want to distribute, the water supply, you will first estimate what is the amount that need to be distributed. So you need to know the per capita demand first. What is the per capita demand for Malaysia? Any of you knows?
230.
Berapa?
230.
Okay, good. Who is it answering?
Dirham.
Dirham. Okay, dirham. No, that is about 230 liter per capita per day, meaning that each of us need 230 liter of water supply per day. 203 liter, maybe around 100 something bottles of 1.5 liter drinking water. 1.5 liter, you buy this 1.5 liter is about 100 something. It's the water that you need for your own use per day. So different country will have different per capita. Like maybe in the US it's about 1200 liter per capita per day. Maybe Canada like 855 liter per capita per day. Australia 700. Maybe countries like in the arid area like Yemen, maybe their per capita is only 60 liter per capita per day because it's very expensive water. Then they need to use efficiently. So the per capita of water demand is the per capita demand is only 60 liter per capita per day. Okay. Okay, the variation in water demand. The water demand is not constant throughout because that is why you have different value for different countries. There are wide variations in the use of water in different seasons, months, days, and hours, and the variation depends on the general habits of people, climate conditions, and character of cities such as industrial, commercial, and residential. Okay. Types of variation in water demand, it can vary based on seasonal variations, monthly variations, daily variations and hourly variations. The simplest one is on the hourly rate of water consumption. You can see that consumption during early morning and also during dinner time, it is the highest. This is the hourly rate water consumption. Okay. Water consumption for various purposes. You have domestic water demand that will include water for your drinking, for your cooking, bathing, clothes washing, utensil, and house washing. So this is after you list all of your needs, then you will be able to determine your per capita demand. Okay. Then you also have this industrial demand. This is water required by factories like paper mills, cloth mill, breweries, sugar refineries. So everything come under industrial use. So usually it's around 20 to 25% of the total demand of the city. This is the industry, but it can vary from town to town. Then you have institution and commercial demand, like that will include office, buildings, warehouse, stores, hotels, shopping centers, what else? Health centers, schools, mosques, temple, railway, and bus stations maybe. And then demand for public use, for public utility purposes, such as for washing and sprinkling on roads. And you have this cleaning of sewers, watering public parks, garden. Maybe you have public fountains in the city. Everything comes under public demand. And then you also have fire demand during fire breakdowns. So you need large quantity of water to throw it, to throw the fire out, to extinguish it. Therefore, usually there is a provision made in the water work to supply, to make sure that sufficient quantity of water or you keep as reserve in the water mains for this purpose. And then you also sometimes have losses and waste from this water supply. This is all that you need to take into account when you calculate the amount of water needed by your community. Okay. And okay, next. Okay, classification of water based on source. So the usually when you talk about sources of water for your water supply, you will talk about surface water and groundwater. Surface water comes from lakes, ponds, streams, rivers, and storage reservoir. So groundwater, open wells, tube wells, artesian wells, springs, infiltration, this comes under groundwater. So usually the basically it's and generally characteristic of surface water, usually the physical and chemical character vary and contain lots of sand, lots of silt and clay, contain oxygen, algae, bacteria, and other microbes. Proper treatment usually is needed before use. That's why in Malaysia, for your water supply, you will have to make sure. Okay, tomorrow we'll talk about the guidelines. In Malaysia, the water supply must come under at least class 2B. Class 2B, then water supply. If not, you need to you cannot use it for water supply. That's why when something happened, any contamination to the rivers or water source or dams, then they will stop the treatment. Because in Malaysia we'll use a very simple treatment because we just want to make sure that the water rate for the public is very cheap. But in this course, we are not going to just follow whatever you have in water treatment in Malaysia, because they are very simple, because they have already controlled the water source. So, but in this class, we will look at various unit operations that are commonly used for water treatment, not only in Malaysia. Then usually the general characteristic of groundwater, they are rich in mineral content, high iron content, harder than surface water, almost no treatment or only disinfection may require. This is generally for groundwater. But for your case study, for your design treatment, I want you to explore more on the various water sources that have been contaminated with the parameters that you choose. So you know, if you have these contaminants in the water source, you know the type of treatment that you need to use. Okay. Okay, the composition of surface and underground water. So actually the composition of surface and underground water is dependent on natural factors like geological, topographical, meteorological. This is one of the factors that affect the quality of surface and underground water. This is the natural factor: geological, topographical, meteorological, hydrological, and biological in the drainage basin. And it varies with seasonal differences in runoff volumes, weather conditions, and water levels. So large natural variations in water quality may therefore be observed even where only a single water course is involved. So human intervention is also significant, gives significant effect on water quality. Some of the effects are the results of hydrological changes, such as the building of dams, you have draining of wetlands and diversion of flow. Okay, so some of the more obvious are your polluting activities. Polluting activities like discharge of domestic, in Malaysia case, discharge of domestic waste, although you have treated your water, your wastewater, your sewage, but because of the many numbers of sewage treatment plants that sometimes are not able to treat up to the standard that is allowable to be discharged to surface water, then you have problem with the water source. Okay, and also you have polluting activities like the industrial, urban, and other wastewaters into the water course, whether it is intentional or accidental, like the spreading of chemicals on agricultural land and in drainage basin. Okay. Okay. And when you talk about the characteristic of surface waters or underground waters, you must be able to relate it to the hydrological characteristics, the hydrologic cycle, because they are all interconnected, because the continental water bodies, like the flowing water, the lake, the reservoirs and groundwaters, they are all interconnected by the hydrologic cycle, and you also have this continental water body, and you also have some intermediate water bodies, whether you have whether they are natural or artificial. Let's say you have land, such as floodplains, marshes, and aquifers. they have characteristics that are hydrologically intermediate between those of these rivers and also lakes and groundwaters. Because wetlands and marshes, they have special important effects on biological characteristic of the water body. So this is everything actually are interconnected. Sometimes you do polluting activities somewhere here, but it will also pollute the ocean or pollute your groundwater through this collation. This is because of this surface runoff. Let's say you use pesticide for your agriculture, but this you use it here, but it will percolate. You go to the groundwater flow and then the ocean and then evaporate, transpiration. So everywhere you will get the effect. Okay. Okay. So quality of aquatic environment. Okay. So the quality of aquatic environment, there are three things that you need to look into: the water quality itself, the composition and state of biological life present in the water body, because they will make the changes, and the physical description of water body. So actually this figure shows the one of the important physical description of water body is the resident time of inland water bodies, because this residence time, they affect the whether you can have rapid contamination clean up or very slow contamination clean up. Because what is resident time? What is resident time? Any of you can answer what is resident time? Hydraulic resident time. Any students? Ingat tak residence time? Hydraulic resident time. What is hydraulic resident time? Because this is the physical description of this water body, affect whether if you contaminate this water body, whether it is easily you can rapidly clean the water, or you need to because it is a very slow clean up, then it causes you more difficulty in treating the water. So, do you know any? Do you all remember what is the hydraulic resident time?
Resident time tu sama macam HRT ke Doktor? Prof.
Yes, HRT. What is HRT? I know HRT is hydraulic resident time. So, can you explain to me what is hydraulic residence time?
Average length Prof?
Average length of what?
Of the compound.
Okay. When you talk about the contaminant, yes, good. Who is it?
Syahira Syamimi, Prof.
Syahira. Okay. Average residence time. Let's say if you talk about the theoretical residence time for a lake, this is the maybe the hydraulic. But then if you talk about the contaminant, it's the average time maybe the water or the contaminant stay in the system. So theoretical residence time for a lake is the total volume of the lake divided by the total outflow rate. So actually residence time is a very important concept for water pollution studies, because it is associated with the time taken for recovery from a pollution incident. Let's say you have incident of pollutant. For example, if you have a short residence time, like here, like this figure show you the common residence time, you can see that our streams, rivers, shallow lakes, bank filtration, karst, alluvial aquifers, sedimentary aquifers, deep aquifers, they have different residence time that can go into 100 years or 1000 years, deep aquifers. So if example, if you have a short residence time as in this river, quite short, so it will aid in recovery of the aquatic system if you have pollution input, because they have rapid dispersion and transport of the waterborne pollutants. Long residence time such that we have in these deep lakes and aquifer, they often result in a very slow recovery from a pollution input. So if you have polluted the aquifer, it will take a very long time for you to recover the water. So pollutants that you store in sediments, they take a long time to be removed from the aquatic system. So you have to really take care of your deep aquifer if you use it for a water source. And even when the water residence time of the water body is short, meaning that if water body, meaning hydraulic retention time, HRT is volume over Q, volume over Q. But let's say if you have even very small aquifer, you still take a very long time for the contaminants to be removed from the system because they have very high residence time. So the contaminants will stay there for a very long time. So this is about residence time. Anything that you want to ask, you can ask now. Okay. Okay, and then it's about when you talk about the lake and reservoir, the important thing is about stratification. Stratification. So actually, and a very important factor influencing water quality in actually relatively still deep waters such as lake and reservoirs is stratification, because you don't have much mixing. Stratification occurs when the water in a lake or reservoirs act as two different bodies with different densities, one floating on the other. In most, actually commonly caused by temperature difference. Then when you have different temperature, maybe the surface and also the water body, so one floating on the other, because they will have because this temperature will affect have effect on the density, and they will have different density. So it's like that you have two different water bodies in one lake. So actually it is most commonly caused by the temperature difference that lead to this difference in density. Usually water, they have water has maximum density at what degree? 4 degrees Celsius, right? But usually if you have different temperature, then you will have to two water bodies, instead of having only one water body in one lake or reservoirs. So water quality in the two water bodies is also subject to different influences, not only temperature. For example, the surface layer receives more sunlight, so and then the lower layer, they are physically separated from the atmosphere, because they are at the lower layer. So this is where usually the lower layer, this is the source of gases such as oxygen that may be in contact with decomposing sediments, and they exert oxygen demand because at the lower layer they don't have this, they have these anoxic conditions occur in bottom sediments, so they take up the oxygen in the dissolved oxygen in the water, so they decrease oxygen concentration compared with the upper layer. So so when you have this anoxic condition in the bottom sediments, so various compounds may increase in the interstitial waters and diffuse from the sediment into the lower water layer. So this one substances produced could be from this reaction. You can have ammonia, nitrate, phosphate, sulfide, silicate, iron and manganese compounds because that's why if you have a lake or reservoirs, not necessarily the quality on the surface layer is the same as the bottom layer. So maybe if you want to sample, you need to sample both the upper layer and also the bottom layer. Okay, and also okay, then we look at this. This is stratification of lakes and rivers. Okay, and this thermal stratification. Just now we talk about this thermal stratification also. So actually this thermal stratification, people have studied this for many years, especially in temperate regions where during spring and summer the surface layer of the water becomes warmer and the density decreases because density increase at lower temperature. So at the surface layer, high temperature, density decrease. So they float upon the colder and denser layer below, and there is a resistance to vertical mixing. They don't have this vertical mixing because it is they're still, the relatively still compared to river. So we have lakes. The lakes can be classified. Into the lakes can be classified according to the frequency of overturn as follows. How many overturn? Monomictic, once a year. Temperate lakes that do not freeze. If they don't freeze, then it's only once a year. Dimictic, twice a year. Temperate lakes that do freeze. So twice a year, you have this mixing. Polymictic, several times a year. Shallow, temperate or tropical lakes. Amictic, no mixing. Arctic or high altitude lakes with permanent ice cover and underground lakes. So these are all the classification of lakes according to the occurrence of thermal stratification and mixing in the water column. Okay, so meaning that this is how many times of mixing in the lake that you will get. So from this here, from this classification of the stratification, the thermal stratification, maybe if you need to use this water body as your source of water, then when you sample, then you need to take into consideration these layers. What time is it now? 1:16. Okay. We'll go until. Do you need a break, or I can just continue on? Can I just continue? Okay. 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 Okay, and then is this is the classification, but actually thermal stratification they does not usually occur in lakes less than about 10 meter deep. So this is only about deep lakes because wind across the lake surface and water flow through the lake tend to encourage mixing. So shallow tropical lakes like we have in Malaysia may be mixed completely several times a year. So this is this one is about very deep lakes, because stratification may persist all year, even in tropical and equatorial regions. If it is very deep lake, even in tropical and equatorial regions, then they have this stratification. Okay. Okay, this is about thermal stratification and rivers. Rivers is a very important because in Malaysia especially that we take most of our water supply from rivers. So actually that's why I think that understanding the discharge regime of river is extremely important when you want to interpret the water quality management measurement, especially suspended sediments, or when you want to determine the flux of sediments or contaminants, the geology, the geography, and also the climate. First we talk about this, and then we talk about the artificial contaminants to the this surface water. But this one is about the geology and also the climate. Okay, this is the tropical rivers. Actually, the regime of tropical rivers largely determined by the annual cycle of our wet and dry seasons. For example, some regimes and some climatic and geographical conditions that may affect our regimes are like the equatorial rivers with one flow peak resulting from we have heavy annual precipitation like from 1,700 to 2,500 millimeter like in Malaysia. And because we have no marked dry season. And then equatorial rivers, sometimes you have two flow peaks produced by precipitation totaling more than 200 millimeter monthly, and you can have over 1,700 annually. So equatorial forest usually predominates in the catchment area. So there are also other classification of these annual cycles of wet and dry season. These are the two important cycle that you need to know. We have one flow peak or you have two flow peaks. Okay, like in Malaysia we have one flow peak. Okay, so but usually when we talk about the grade of the tropics, they do not fall exclusively into any of the categories that we have discussed, because their drainage basins extends over many regions of differing climate and vegetation. For example, the Congo River in Africa, which is the second largest river in Africa, shorter only than the Nile, second largest river in the world by discharge volume. So combinations of regimes of the equatorial wet region and the tropical is highest in April, 76,000 cubic per second, and lowest in July, 32,000 cubic meter per second. So you cannot classify because they don't have, because they fall into many categories. The rivers are along many regions. So this another example is the Amazon river in South America. This is the largest river by discharge volume of water in the world. So disputed longest river in the world in comparison to the Nile. Complex flow regime because of the different precipitation patterns of its main tributary. So this is also you cannot single out any regions when you talk about the great rivers. And also another example is the Nile River in Africa. Yeah? So the longest river in Africa, this one it exhibits the most complex regime of all African rivers, extending over many widely different climatic zones. Because it is a very long, so they have different climatic zones, so you cannot single out whether this is what type of river when you talk about the this annual cycle of the river. Okay, so and also you have this large river in Asia, usually like usually the large river in Asia, they flow generally southward, have their sources in the mountains and flow through very climatic conditions before discharging to the sea. For example, the Ganges and Irrawaddy, they receive snowmelt from the Himalaya and southern Tibet from April to June, and the flow rate is just beginning to decline when the July monsoon begins. So flooding can occur from July to October. So of all these rivers, you cannot easily, you cannot simplify anything, because it is a very large and long rivers. These are some other examples. I just put some examples here so that you know not only Malaysian rivers, but basically you need to also know what happened in the world. The Ganges and Irrawaddy, the Mekong, the Indus in Western Asia, the Tigris and Euphrates. So meaning that when you talk about the rivers, then you need to also know what happened about all rivers in the world, not only in Malaysia. When you talk about the monsoon effect on the rivers, because this one, the monsoon effect will have a very strong relation with the quality of water. This is the not artificial contaminants, but this is natural, natural contaminants. Okay. So because you know the erosion rates are thus extremely variable, because you have the different precipitation, you have different rainfall, different regions. So erosion rate are extremely variable, with the highest rate occurring usually in mountain streams where human intervention has resulted in extensive damage to vegetation. That's why because sediment loads usually for water supply, this is one of the very important parameter that need to be taken into account. So mean annual sediment loads of some major rivers, you can see here from Amazon, what is the basin area, 6,300 times 10 to the power of 3 kilometers squared. So the mean annual sediment load is what is. Then you can compare when you do your water treatment plant design. Then you can take that river from when you discuss about the location, then you can also compare with whatever you know from the these major rivers in the world, compared to what you are talking about. So you can also see whether they have this mean annual sediment load, or you can also calculate based on the turbidity of the river to compare with what you have with great rivers, with other great rivers. Okay. Okay. And characteristic of groundwater. Just now we talk about rivers, and now we want to talk about some introduction about the characteristic of groundwater. So I expect some of you will also do water treatment plant for source from groundwater that have been contaminated with any of the three parameters that you choose. Okay, I will give I think some percentage for those who some marks for those who take the challenge to treat very difficult parameters. Kalau you just choose turbidity, you just choose the very simple one, turbidity. What else that are very simple? Maybe not that bad, BOD. So maybe the marks that you will get is a bit lower, maybe. But if you take the water source that have been contaminated by pesticides, by these microbes, maybe you will get this extra mark. Okay. So characteristics of groundwater. Actually, groundwater, as I explained just now, is where the water is held in the pore space of sediments, such as sands or gravels, or in the fissures of fractured rock, such as crystalline rock and limestone. So the body of rock or sediments containing in the water, you call it aquifer. Aquifer, and the upper water level in here, this is the water table. This is the terms that you should know. Aquifer, body of rock containing water, water table, the upper water level in the saturated body. Okay, I think most of you are already familiar with all these terms actually, because you have taken a few you have taken water supply course. Okay, and also typically groundwater, they have very steady flow pattern because the velocity in the groundwater is governed mainly by the porosity and permeability of the material. So porosity and permeability of the material is fixed. Usually this depending on the location. What is the porosity? The ratio of pore and fissure volume to the total volume of the media. Meaning the ratio of pore. The ratio of pore and fissure volume. Fissure is breakage, the breakage in the stone, whatever, to the total volume of the media. And it also depends on the permeability. Permeability is a measure of the ease with which fluids in general may pass through the media under a potential gradient. Okay. Okay, and this is what you call for the the fluids through media, and you also call this hydraulic conductivity. I think you have come across this term, this permeability as hydraulic conductivity in your earlier class. Okay. Okay, now is 1:30. Okay, I continue on. Okay, the quality of the groundwater actually depends on the compositions of the recharged water, the interactions between the water and the soil, gas and rocks, with which it comes into contact in the unsaturated zone, residence time and reaction that take place within the aquifer. Okay, so the principal processes influencing water quality in aquifers: first, physical. You can have dispersion, dilution, filtration, and gas movement. Geochemical, complexation. I think you have come across this terms when you have some of you have done this wastewater treatment: complexation, acid-base reaction, oxidation reduction, precipitation solution, and adsorption desorption. So we will once again have this process in the water treatment. And also biochemical, if you have microbial respiration and decay, and also cell synthesis. Yeah? So these are the principal process influencing water quality in aquifers. So groundwater quality is also influenced by the effect of human activities. Okay, so you say that it is in the especially aquifer, so actually they are also affected by human activities, because you can have artificial pollution like domestic sewage and latrines, municipal solid waste, agricultural waste and manure, industrial waste, including tipping, direct injection, spillage and leakage. Land use in areas surrounding boreholes and where aquifers are recharged. Okay, natural processes affecting, I think this is, where is the, I want to explain to you about the confined and unconfined aquifer. Okay, okay, first before talking about this quality of groundwater, I want you to understand what is the confined and unconfined aquifer, because this is important for you to be able to understand why certain groundwater has different characteristics. So actually a confined aquifer here, this is overlain by an impermeable layer that prevents recharge, and kalau they prevent recharge, then it also prevent contamination by rainfall or surface water. So recharge of confined aquifers occurs where the permeable rock outcrops near the surface, which may be some distance from the area of exploitation. So this is confined aquifer. So it is this is a feature that make this control of quality and pollution more difficult. Okay, some aquifers are not perfectly confined, and we call this unconfined aquifer, because this is the unsaturated zone. So you will let's say you have this surface runoff, it can go to the saturated zone, and it will also affect the confined aquifer. So this is where we call this unconfined aquifer, and this is confined aquifer. Okay. Okay. So you can see that this confined aquifer, they are less vulnerable than unconfined aquifers to pollution outside the recharge zone, because surface water and contaminants, they cannot percolate to the water table. So, but if contamination does occur, it is often difficult to remedy, because these confined aquifers, it is not vulnerable to contaminants. But if it does occur, if contaminant does occur, it's difficult to recover, to remedy, because confined aquifers are usually deep, and the number of points where contaminated water may be pumped out is limited. So given the limited outflow, these contaminants may also be increasingly concentrated in confined aquifers, and sometimes if you want to extract this groundwater, this is it will restrict these parameters, the contaminants may restrict your need to extract the water here. But sometimes, although unconfined aquifers, it is vulnerable to contaminants, because there's a wider area here which they are recharged, and the contamination may enter, and they have greater interaction with polluted surface water bodies. Sometimes here you have this agriculture, so they have this, and this contaminant. Of course, if it is easily entered, it will go to your groundwater. So actually the risk of contamination will depend on the depth of the overlying unsaturated layer this year. So how big the area is, the unsaturated zone, the rate of infiltration to the water table, and the land use in areas surrounding the sources here. Okay. So this is, let's say, if you take groundwater, you have to also look at the location, whether it is confined aquifer or unconfined aquifer. If your source is from groundwater, okay. And when we talk about the water quality, the quality of groundwater, just now I said that depends on the composition of the recharged water, the interaction between the water and the soil, the soil gauge and rocks with which it comes into contact in the unsaturated zone, and residence time, and reactions that take place within the aquifer. So considerable variation can be found because you have these many types that you are dependent on, the quality, and even in the same general area, especially where rocks of different compositions and solubility occur. Sometimes you have these types of rocks, then the pollution, the contamination, because it's soluble, so it vary with time. So your the contaminant will also vary with time. Okay. Okay. So just now I told you that groundwater is also influenced by the effect on human activities which cause pollution at the land surface, because most groundwater originates by recharge of rainwater infiltrating from the surface. So the rainwater itself, that you have may have also sometimes increased acidity because of this human activity. They evaporate, and also it will be in the rainfall, and it will the acids will go into this groundwater. The unsaturated zone, they can help reduce the concentration of some pollutants entering the groundwater, especially microorganisms. Like if you have the septic tank, the leaching from the septic tank will not go into this confined unsaturated zone of this groundwater. But let's say if you have microorganisms there, it can also act as a store of contaminants that enter water directly from, so it will accumulate, like what when you have things from these abandoned wells, and also sometimes septic tanks, and therefore the possibility of natural decontamination process is also difficult at this very deep well. Okay. And artificial pollution, like just now we talked about this one, human activities is artificial pollution to the groundwater. So domestic sewage and latrines, municipal solid waste, agricultural waste and manure, industrial waste, land use in areas surrounding boreholes and where aquifers are recharged. So the contamination of groundwater can sometimes be very complex process, because when you have contaminants like the agricultural chemicals, because it's spread over large sections of the aquifer, the recharge area may take decades to appear in groundwater, and perhaps longer to disappear even after you have stopped this activity, like the agricultural activity, because and also if you have like major accidental spills or other point sources of pollutants that may initially cause rapid local contaminations, then spread through the aquifer. When you spread on the surface, it looks very rapid, but then after they enter the groundwater, it will be there for a very long time. So pollutants that are fully soluble in water and about the same density will spread through the aquifer at a rate related to the groundwater flow velocity. So if the flow velocity is very low, like if you have this chloride contaminated water from sewage, because the velocity of the flow in the groundwater is very low, so it will be there for a long time. So dense compound like chlorinated solvents. Let's say if you sometimes industries they just dump these chlorinated solvents. So it's very dense compounds. So it will move vertically downwards. So it will accumulate at the bottom of your aquifer. So it is very important that especially like the OE, they are taking this thing into serious, become a very serious issue if industries to dam their chlorinated solvents into maybe it's at one of our soil area, but it will go into our groundwater. So it is very dangerous. Okay. So and also just now you said about this here when you talk about natural processes affecting water quality. Sometimes you also have natural processes like torrential rainfalls and hurricanes that lead to excessive erosion and landslides, which in turn increase the content of suspended material in affected rivers and lakes. And then you have seasonal overturn of the water in some lakes and can bring water with little or no dissolved oxygen to the surface. And many groundwaters are naturally high in carbonates. It is hardness. It is something that we will carefully look into here. The hardness of groundwater, thus necessitating their treatment before use for certain industrial applications. Because hardness, even though it is sometimes it is not harmful, but they will give a great effect if the water supply is used for industry. Groundwater in some regions contains specific ions such as fluoride and toxic elements such as arsenic and selenium in quantities that are harmful to health. So these are natural processes that will affect groundwater. Okay. So this is this table here show you the important processes affecting water quality. Water body, hydrological like dilution, it will affect all water bodies. Evaporation, only surface water. Percolation and leaching, groundwaters. Suspension and settling, surface water. These are the major processes within the water body and how the effect on the water body, whether it is only on the surface, whether it affects groundwater or throughout. Okay, physical gas exchange with atmosphere, mostly rivers and lake, volatilization, mostly rivers and lake, absorption and desorption. These are the processes that you can have a look at if you want to understand more on the chemicals or the other parameters that you choose to affect the water, the source of water that you choose for your treatment plant. Okay. What time is it now? 1:47. So we have another about 10 minutes. So I will go I will try to finish this part. Ada banyak lagi. So I will try to finish these two slides. Okay, concentration on. Okay. I cannot see here. Sure. Okay, this is the tajuk concentration of chemicals in river water. So this is natural variations. We are talking about the concentrations of chemicals in river water. This is the naturally occurring chemicals. So actually under the influence of major environmental factors, the concentrations of many chemicals in river water, actually they are liable to change from season to season actually, and in small watersheds. When we say small watersheds, it is less than 100 kilometers squared. The influence of a single factor can cause variation of several orders of magnitude. So water quality is generally more constant in watershed greater than 100,000 kilometers squared. This is also true when you want to design a wastewater treatment plant. Remember, if it is a big, large water treatment plant serving like maybe the regional treatment plant serving like 100,000 PE. So whenever there is a change in the wastewater, it will not really affect the system. But if it is from a small populated community that you build your wastewater treatment plant, if there is a small change in the influence, it will affect the quality of the wastewater. Happen also in the river. So this figure here show the common range of total dissolved solids in inland river. So these natural variations, usually the natural variation, if you talk about the chemicals in rivers, the natural variations usually are through the total dissolved solids. Total dissolved solid usually is the sum of silica plus major ions in the water. Okay, so when you want to measure total dissolved solids, the close approximate value is the EC, electrical conductivity. So when you have your wastewater characteristic that you want to treat, you get from the literature what is the EC content of the characteristic of the river or water body that you have chosen. Then if the EC is high, there must be a possibility whether if it is not from surface water or if it is not from industries, then you know that there must be high amount of silica or the major ions in the water. So you need to find out before you decide on the treatment for your source of water. Okay, so you can see that here total dissolved solids, this is the naturally occurring dissolved solids. So you can see here rains, streams, rivers, lakes with outlet, lakes without outlet, superficial aquifers and deep aquifers. So you can see that lakes without outlet and deep aquifers, usually they have high total dissolved solid, or you can see that the electrical conductivity, the EC parameters is high. Parameters is high, okay. And elemental composition of a river particulate. The elemental composition of river particulate usually is less variable than the dissolved concentration for the same element. Actually, this is true for major elements like aluminium, iron, silicon, calcium, magnesium, sodium, potassium, manganese, titanium, and phosphorus. But for trace elements like arsenic, you have this cadmium, cobalt, chromium, elements in particular is very similar in tropical rivers and in temperate and cold rivers. Okay, so this aluminium, iron, calcium, and sodium. So usually they are the rest they are very similar whether they are in tropical rivers or in cold rivers. The composition, but this compound, the tendency for a chemical to be present in the soluble form, separated from material in solution. These chemical elements, they have higher tendency to be in soluble form. So this is soluble transport index of chemicals, meaning that if they have a very high soluble transport index, meaning that in the rivers, in the tropical rivers, in the cold rivers, they will have different concentration. But with chemicals with lower soluble transport index, when you see the rivers in tropical climate or in cold climate, usually they have about the same concentration of these chemicals. So when you study the characteristic of the river waters that you want to treat, then you can also study about the chemicals present, whether you are choosing tropical rivers or cold rivers in cold climate. Then you can also look at how these elements present in the wastewater characteristic that you have chosen. Okay. One last slide. One last slide on the common water users here. Actually, all water users, they have impacts on the quality of the aquatic, such as storing water in reservoirs or transferring water from one drainage area to another. So actually, human use of water for almost all purposes results in the deterioration of water quality and generally limits the further potential use of the water. Okay, and usually we develop these three strategies to resolve the conflicts between quality deterioration and water use. The quality of water and of the aquatic environment is determined, and water use procedures that prevent deterioration are adopted. Wastes are treated before discharge to a water body in order to control pollution, and unsatisfactory water is treated before use in order to meet specific water quality requirements. Okay. So you know that human activities are source of particularly dissolved on volatile materials, which may eventually reach the water, the surface water or the groundwater. So you can see how these water users, whether you consume, whether it will contaminate or not. So domestic, livestock, the only activities that will not contaminate the water body is hydroelectric power generation. That's why it is a very green energy if you can also have hydroelectric power generation. Okay. Okay, one last slide. Sorry. One last slide. I want to finish this before going into the different topic. Then when you look at the freshwater quality deterioration at the global level, so this is you can see that pathogens reverse 3x, meaning that globally occurring or locally severe deterioration, XX important deterioration, 1X occasional or regional deterioration, 0 rare deterioration, 0 not relevant. You can see pathogens in rivers and lakes and reservoirs and also groundwaters. They all have pathogen. Suspended solids, rivers, reservoir. Decomposable organic matter, you can see that rivers, reservoirs, lakes and groundwaters. Eutrophication, lakes, reservoirs and rivers. Nitrate as pollutant, groundwater. So make sure. So when you look at the characteristic of the water source that you want to treat, you look at the nitrate if you use groundwater. Heavy metals also very important in depending on the river, depending on the human activity they have in rivers, lakes, reservoirs, groundwater. Groundwater also. Organic micropollutants, rivers, reservoir, groundwater. Acidification, lakes. Changes of hydrological regimes, rivers, lakes and reservoirs, and also less effect on the groundwater. Okay, so this I will continue 1 hour for this slide, and also I will talk about the regulation in Malaysia before we go into the different treatment for your for your water treatment plant. Okay, any question? Okay, thank you everyone. It's already 2 o'clock. Okay, it's already 2 o'clock. Okay, we finish and we see see you again tomorrow 9 to 10, right?
Thank you, Prof. See you.
Okay. Are you all in? I've been lecturing and I don't ask you questions, so there is no interaction. Okay, I'll try to arrange the physical class, but if possible, can it be okay, it's okay. I will tell you. This week is not. Maybe next week I will ask what is AST1 means. I don't know where the location is of our room. Okay. Okay. So tomorrow we'll see you 9 to 10. Okay. Okay. Thank you.
Thank you, bro.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.